systems of three equations with three unknowns using the method of elimination. So in the previous section, 1.3, I believe, we talked about how to solve systems of two equations, two unknowns. I think we did that in section 1.2. So before we see how this works, let's do a couple of warm-up activities. So suppose we have an example like this where we want to answer this question: is point 2 comma negative 1 the solution of this system? We have 2x minus y equals 5, and 5x plus 2y equals 8. Okay, so that's the question we have. For us to show this, all we have to do is to substitute for x and y with these values and see if the left side and the right side agree with each other. If you do this with one of these equations and it checks out, that's not sufficient checking. You have to check with the second equation as well. Only if this point holds for both of these equations, this is a solution of the system. Not just if these values check out in one of these equations. That wouldn't be enough. So let's do that. So first, we're going to use the first equation using 2x minus y equals 5. Let's plug in. So 2 times 2 minus 1. We're asking if the left side is equal to the right side. So we have 4 here, minus 1 is plus 1, and we have 5 equals 5, which checks out. So now let's check the second equation, using 5x plus 2y equals 8. Plugging in with that point again, we have 5 times 2 plus 2 times negative 1 equals 8. Then we have 10 minus 2 equals 8. The left side is 8. The right side is 8. So yes. So the answer to this question is yes. 2 comma negative 1 is a solution of the system. Okay, so let's do another example. This time we're going to do the same thing but with a larger system, with a system of 3 equations and 3 unknowns. So we want to answer, or we want to show if this point, 2 comma negative 3, 1, a solution of this system. We have 4x minus z equals 7. Move this up a little bit. And then 8x plus 5y minus z equals 0, minus x minus y plus 5z equals 6. So at this point, it would be a good idea for you to pause the video, check this point on your own to see whether it's a solution or not, then come back to the video and watch the rest of this. Okay, so I'm assuming you've done that and now you're back. So I'm going to start with the first equation using 4x minus z equals 7. Let's plug in. We have 4 times 2 minus z, which is 1. And the question is the left and the right hand side agree? Okay, so we have 8 minus 1 equals 7. 7 equals 7, so it checks out. Let's check the second equation here. So using 8x plus 5y minus z equals 0. We have minus, the 8 times x, x is 2, so I'm going to plug in, plus 5y, 5 times y is minus 3, minus z, z is 1, and we're checking to see if the left and the right agree. So let's see. We have 16 here, minus 15, minus 1 equals 0. That's 16 minus 16 equals 0. So definitely 0 equals 0, and that checks out also. We're not done though, because we have to make sure that this solution is valid in the last equation. So let's do that. So using minus x minus y plus 5z equals 6, and substituting with those coordinates, minus 6 would be minus 2, minus y would be minus 3, right? We're just plugging in this point here, plus 5 times 1, and we want to know if the left side is equal to the right side. So here we have minus 2, here we have positive 3, then we have positive 5 equals 6. This would be 5 plus 3 is 8, minus 2 is 6, equals 6, so it checks out. So once again, this point right here is a solution. Is a solution of the system. Okay, so this was just to get us warmed up to learn about how to solve systems of 3 equations and 3 unknowns. Okay, so let's just jump right in with an example. Suppose we want to solve this system. We have x plus 4y minus 3z equals minus 8, 3x minus y plus 3z equals 12, and then x plus y plus 6z equals 1. Okay, so let's label these 3 equations as equation 1, equation 2, equation 3. So the big picture in this, before we get into the details, the big picture is reduce this system of 3 equations, 3 unknowns, to 2 equations, 2 unknowns. And we already know how to solve those, right, from previous sections. Then solve that smaller system of 2 equations with 2 unknowns. With those variables known, we'll come back to this system, to the original system, plug for any 2 variables that we've figured out, and solve for the 3rd variable. So that's just a big picture of what we intend to achieve here. Now, how to do it is the question, right? The way we do that is we pick 2 pairs of these equations. So one pair can be equation 1 and 2. The other one could be 2 and 3 or 1 and 3. What I do is I pick, just looking at these equations. This equation 3 seems to be an easy equation. So I'm going to include this equation 3 in both of my pairs. So one pair will be 1 and 3. The second pair would be 2 and 3. Okay, so let's do that. That's equation 1, and then equation 3. So this would be 1 and 3. Let's take the other pair as 2 and 3. So we have 3x minus y plus 3z equals 12. X plus y plus 6z equals 1. And just to be clear, this is equation 2, and this is equation 3. Now, we want to eliminate one of these variables, either x or y or z, from both of these pairs of equations. At this point, we have the choice to pick which variable we should eliminate. At this point, we have that choice. But once you make that choice for this pair, for the other pair, you must eliminate the same variable. You can't eliminate another variable from this one. So you can pick which variable to choose at the beginning, but once you make that choice, it'll be the same variable that you must eliminate from both pairs. Okay, so looking at this, these are really easy numbers for all of these variables. I'll just go ahead and say, I want to eliminate the x variable, right? You could decide to eliminate the y variables, because here, if you take a look, you can simply add these two equations and the y's will drop out because they have equal and opposite coefficients. It's up to you, and any choice is a valid choice. So going with x, eliminating x, I will multiply this equation by minus 1, right? Because I want this x to have a different but an opposite sign, but equal to the coefficient for this x variable in the other equation. You can multiply this one by minus 1. It makes no difference. Okay, so let's do that. Minus x, I'm just distributing the minus 1 into all terms in the top equation. Minus 4y plus 3z equals positive 8, right? Let's not forget that this distributes itself to both sides. So it's going to go to this, then to this, then to the last one. Okay, the bottom equation stays the same. So x plus y plus 6z equals 1. Now we can add these two equations together. So adding them together, minus x plus x add up to 0, which is good because that's what we intended, right? We intended to eliminate variable x. Minus 4y plus y adds up to minus 3y. Then 3z plus 6z will add up to 9z. And the other side, it's equal to 9, right? 8 plus 1 is 9. So this is one of the equations. So let's call this reduced equation A, right? Reduced because it no longer has 3 variables. It's got 2 variables, y and z. Let's do the same thing here. So we eliminate the variable x in this pair. We have to do the same thing here. So let's multiply the bottom equation by minus 3. Then we have the top equation doesn't change, right, for now. So equals 12. Now distributing this negative 3, we have negative 3x, negative 3y, negative 18z equals minus 3. Now let's add those two equations together. 3x plus minus 3x is 0. Minus y plus minus 3y, that's minus 4y. 3z plus minus 18z, that'll give us minus 15z. And 12 minus 3 is just 9. So we have another reduced equation here with number of variables reduced to only 2. And let's call this reduced equation B. Okay, now we can form a new system that with these two reduced equations. So from here and from here, let's put them together. We have minus 3y plus 9z equals 9, minus 4y minus 15z equals 9. Okay, so now this is a system of two equations, two unknowns, and we know perfectly well how to solve these, right? So let's pick any of these variables that is easier to eliminate and eliminate that one. Looking at these coefficients, the coefficients of the y variable are smaller, and so I will eliminate the y terms. I'm going to multiply the top equation by 4, positive 4. So that'll give me negative 12 here, and I want a positive 12 here. So I need to multiply this by minus 3. Okay, so I'm picking numbers so that I can get equal but opposite numbers as coefficients. All right, so let's carry out the rest of this solution. Distributing the 4. At this point, it would be good if you pause the video, solve for y and z, and then go back to the video and see what I got compared with your solution. You get good exercise that way. So minus 12y plus 36z equals 36. Distributing the minus 3, we get positive 12y. Minus 3 times minus 15 is positive 45z, then equals minus 3 times 9, we've got minus 27. So let's add these two equations together. Minus 12y plus 12y drop out. 36z plus 45z, what do we get? We get 81z equals, right? And then we get 36 minus 27, and we get positive 9. Okay, so at this point, we can easily solve for z by dividing 9 by 81, and that'll give us 1 over 9. So we found the value of z. Let's plug this number into any of the reduced equations and solve for y. Looking at these equations, it'll be easier if I pick equation 1, right? Because the coefficient of z in that equation is 9, and when I plug in this fraction in there, 9 times 1 over 9 is going to be 1. And that's easier than plugging it into this equation where we would have minus 15 over 9. In the end, whichever equation you pick, you will get the same answer, but it's easier if we pick the first equation. So let me use that. So we're going to use using minus 3y plus 9z equals 9, minus 3y plus 9 times 1 over 9 equals 9. So distributing or simplifying, we get minus 3y plus 1 equals 9, minus 3y equals 9 minus 1, and minus 3y equals 8, and 8y, so y will be equal to minus 8 over 3. So we have z here, and we have y here figured out. So let's find x. If I scroll up, we can pick any of these original equations for that purpose. So we can pick this one and then plug in for z and y, which we already know, and then solve for x. So let me plug the numbers I have into this easier equation. I'm going to write it here. So from here, I'm going to put a box here. So using x plus y plus 6z equals 1. So we have x, for which we're solving, plus y, which is minus 8 over 3, plus 6z, and z is 1 over 9, and the other side is equal to 1. Okay, so now the rest is just doing the arithmetic on this, right? So let's do that. So we have x minus 8 over 3 plus 6 over 9. We have 6 over 9 there, but we can simplify it, right? Because 3 is a common factor. So we can end up with 2 over 3 after simplifying. Multiply this by 1/9, you get 6 over 9. Then simplify 6 over 9, and you get 2/3 equals 1. Okay, we can easily subtract these, right? So we can do x, because minus 8 over 3 plus 2 over 3, they have already the common denominator. So minus 8 plus 2, that's minus 6, over 3, that's minus 2. So like that, and this you already know is minus 2 equals 1, and therefore we have x equals 2 plus 1, x equals 3. So we have x, we have y, and we have z. Let's put them all together. We have 3 comma, because we can write the answer in this form, x comma y comma z. And to do that, we have 3. For y, we have minus 8 over 3, comma 1 over 9. And that's the final answer. That is the point in three-dimensional space, x, y, z, where those 3 lines intersect. Okay, so that's the interpretation of that point or solution we found. At that point, those 3 equations are equal to each other. Okay, I trust that you will ask me any questions you have on the underneath on the discussion board right under the video. Okay, let's move to another example. This one is a word problem. So we have a movie theater that charges $8 for adults, $4.50 for children, and $6 for senior citizens. Okay. Okay, so here is the question before us. First, let's get a feel for what they're asking us here, given this information. They want to know how many adults, children, and senior citizens went to the theater that day, right? So this is 3 unknowns that they're asking us. So if we have 3 unknowns in a problem, then we need to have 3 equations to be able to solve it. Okay, so that's initially that's the good information to have. Now, because it's how many of each of these categories of customers that we're looking for, so let's give them variable. Let's give these unknowns variables, right? That's the first step in solving a word problem. So A for number of adults that went to the theater that day, right? And then let's pick C for the same thing for the number of children, and S for senior citizens, right? So number of senior citizens that went to the theater that day. Given these variables, now let's attach, read the problem and attach information to this. Okay, a movie theater charges $8 for adults. So I'm going to attach that information to this variable here. $8, right? Then for children, they're paying $4.50. I'm going to attach that information here. For senior citizens, that price is $6. Okay. So obviously, this is old data, right? We know the prices are much higher than these today. Okay. So now that we took care of that information, we've been able to translate all of that information. So if somebody rips this piece of page away from me, I'm not going to miss it. I've already accounted for that information. One day the theater sold 405 tickets and collected this much in receipts. Great. So keep in mind, we need 3 equations, right? Because we have 3 unknowns to solve for. So if the theater sold 405 tickets, we can translate that as A plus C plus S equals 405 tickets, right? So let's do that. So A plus C plus S equals 405. That's one of the equations. Then it says that the theater collected this much in receipts. That's from all the tickets, all the 405 tickets. Okay, great. We can write a second equation based on that information. Because we can say that just looking at these prices, ticket prices, each adult ticket, it costs the customer $8, so 8A plus 4.5C plus 6S must add up to $2,320, which is the information given to us here. Okay, so that's the second equation. Where is the third equation going to come from? Well, there's a piece of information that we were given and I haven't used yet, and that is, it says there were twice as many children's tickets sold as adult tickets. So for every adult that went to the theater that day, 2 children went to the theater. So that's going to give us the third equation we need. So C, or the number of children, is twice the number of adults. Okay, so that's all the 3 equations we need. This is easier than the problem example we did just now, because in that problem we had to decide which variable to eliminate. Here it's already been decided for us, right? In these two equations, we can substitute for C with 2A. That will eliminate C, and then we'll use A and S to find out what those values are, and then we'll come back and plug in here and find the variable C. So let's do that. So I'm going to plug into these two equations for C with 2A. We will have, instead of C, we have 2A. Instead of S, we just have S there, 405. And then that one, 8A plus 4.5 times 2A, right? Instead of C, we're plugging in 2A. 2A plus 6S equals 2,320. Now let's simplify this. We have A plus 2A, that is 3A, plus S equals 405. This 8A, that's 2 times 4.5, that's 9A plus 8A, that's 17A, plus 6S equals 2,320. So now we have two equations, two unknowns. We can easily solve these. Let me multiply the top equation by minus 6, and then we get minus 18A minus 6S equals minus 405 times 6. Let's see, we get, let me double check this number. So 405 times minus 6 is 2,430. So minus 2,430. And then the bottom equation stays as it is. Let's add these two equations. The S terms drop out. Minus 18A plus 17A. That is minus A equals minus 2,430 plus 2,320. That's minus 110. So minus A equals minus 110. That will give us A equals 110 tickets, right? So if adult tickets were this many and children were twice as many, given this equation, then we can right away tell that children were 2 times 110, or there were 220 children that went to the theater that way. And remember that we had total 405 tickets sold. So the senior citizens, the number of tickets that were sold to senior citizens is going to be 405 minus these two added together, right? So a number of citizen tickets would be 75 tickets. Okay, so 80% of this problem, at least 80%, is setting up this system. Once you have that, the rest is going to fall into place. This wraps up section 2.1. Please post your questions on the discussion board right underneath this video, or send me an email about it, or join the WebEx session. For now, have a nice day, and I'll see you next time.